Hello students, and welcome to A Moment in Math. My name's Elise Brown and I work with the Mississippi Department of Education and the University of Mississippi. My normal job is working with teachers as a professional development coordinator, but today I get the special privilege of being your math teacher. So hopefully we're going to get through this lesson where we're looking at an 8th grade standard on functions, and this lesson is called Putting the Fun in Functions. Before we get started, let's gather up the materials that you're going to need throughout this lesson. So I'm going to come over to my PowerPoint to show you that the first things that we are going to need for this lesson is going to be paper. Now, graph paper is going to work best, but any paper will do. You're also going to need something to write with. That can be a pencil, it could be a pen, you might use markers, whatever you have handy will be fine. You're also going to need objects to count with. So if you have coins, cereal, candy, paper clips, anything you have a lot of that you can count with is going to work for that situation. And the last thing you are going to need is a ruler or some kind of straight edge so that you can make straight lines while we are working today. So I'm going to give you a moment to go gather your materials, and then we will come right back to start our lesson. Okay, hopefully you have what you need at this point. Now, our goal today, remember, we're putting the fun in functions. This is an actual real life skill that you're going to need to have. Sometimes you think, when am I ever going to use this in math class? This is one of those standards you are going to use. So while we're looking at this 8th grade function standard number 4, we have 3 goals for our lesson together. Our first goal is to build a linear relationship. So we're going to build some models that represent situations that we are reading throughout the day. Our second goal is going to be identify, and there are 2 things I want you to be able to identify in our lesson. The first is going to be the rate of change, and the second is going to be the initial value of a linear function. And then our last goal for our time together is going to be to interpret. So we're going to look at some scenarios, some real life situations of when you would see a linear function, and you're going to tell me, what does the rate of change mean in this situation, or what does the initial value mean in this situation? So 3 goals for us to get through in just a little bit of time together. So I told you we were going to look at multiple representations of these linear functions. So a lot of these you might have seen before when working with linear relationships in your slope-intercept form as an 8th grader. But we are going to look specifically at tables as function models, which is an XY table of value. This is where we're going to keep track of how X controls the Y in a scenario. We are also going to graph our lines on an XY coordinate plane. We're going to look at scenarios that would give us a linear function because it has a constant rate of change. And we're also going to look at our rules for linear functions. Now, before you might have seen these rules as y equals mx plus b or slope-intercept form, but today we're going to look at them in function notation where it says f of x equals mx plus b, with that f of x replacing that y being that function notation. And we need to know some vocabulary because I've said a lot of terms that might not be familiar to you. So let's go over 3 terms that are going to help you be successful today. The first term I want us to look at is initial value. You might have seen this in 7th grade or earlier in the school year as your y-intercept. So this is the beginning of a situation that you are given. This might be a subscription fee or a service fee that you have to pay on something. When I'm looking at a table, I'm going to see that where x is 0, my y is going to be my initial value. Or if I'm looking at a graph, you might see it as the y-intercept. That is where the line is going to cross over the y-axis, and that y value is going to be your initial value or your y-intercept. The second term we need to know for this lesson is rate of change. This is how the output quantity changes based off of the input. How does the independent variable change the dependent variable? You might have heard of this as slope before. in your previous classes. So again, looking at your table, you might have to look at how the y changes and how the x changes. If I'm looking at a graph, I might think of that as rise over run. But either way, we're just looking at what is that constant change that we're seeing over and over again that is giving us a line. And the last term that we're going to look at is linear relationships. This is any relationship between an x and y that's going to create a line when we graph it. So for example, we might have positive, constant, or negative slopes or rates of change. And just think about this in a real life context. We might have something that has an increasing fee depending on how many of something we purchase or that we do. So if I order an Uber and I have to pay a service fee, but I also have to pay a certain amount per mile, that's going to give me an increasing function. If I have a subscription to something and I only pay that monthly subscription, like a Netflix fee, that would be a constant. That would give me that straight line because my rate of change is 0. Nothing is changing about paying extra. And then if something decreases every time the other one goes up, then that's going to be a negative or decreasing function. So for example, when the weather is colder, so the temperature goes down, our flu cases tend to go up. So that opposite pull in numbers is what gives us a decreasing function. So I told you we'd have fun today. And so I don't know about you, but whenever I have to do something I don't love doing, I like to add a little music to it. So when I'm working out or doing chores at home, I play some music. So I gave us a situation today dealing with music called Music Mania. I want you to take a moment to read the scenario that you see on your screen. And now we're going to read it one more time. I want you to read it along with me because we're going to pull out some important information. You want to download new albums to play while you exercise. You find a site that offers MP3 downloads of albums with the following price structure: a $3 fixed fee for a monthly subscription, plus a charge of $2 per album downloaded. So here's what we're going to do together to reach our goals for this lesson. The first task we are going to complete together is constructing a table. We're going to predict how much it would cost for us to download 4, 5, or 10 albums. The second thing we're going to do is we are going to plot those data points on a coordinate plane. And then the last thing we're going to do is we are going to construct a linear function to model the relationship. And that is just a fancy way of saying we're going to write a rule for the scenario so that we can make lots of predictions later on if needed. So the easiest way for us to do this is to build. So we're going to come away from our PowerPoint and we are going to actually build this scenario. And I have it up here just so that we can kind of keep track of what we are doing for this problem. But I do want us to pay attention to a few key things in this problem. I want us to keep in mind that our $3 is a fixed fee. That means it's going to happen over and over and over again every month, even if I don't buy any albums that month. The other thing I need to know is that I am adding on a charge of $2 per album downloaded. So every time I buy an album, I have to pay an extra $2 for that album. And again, we are going to make a table, graph, and rule. And to help us visualize that, we are going to come down here and we're going to build. So I asked you to find some items that you could use to count with. I have these little green tiles here because green reminds me of money, and so I thought it would be a great way for us to visualize. Now, if you didn't have any items at home to help you count, feel free to draw the picture of the tiles along with me as we work this out. All right, so our situation told us that every single month I have to pay $3 no matter what. So even if I purchase 0 albums, I have to pay a subscription of $3. Now, when I want to buy 1 album, I still have to pay my $3, but then I pay $2 for that 1 album that I purchased. If I'm buying 2 albums, again, I still have to pay my $3 monthly subscription. And on top of that, I have to pay $2 for each of the albums that I downloaded. And then my last example is going to be if I bought 3 albums, I have to pay my $3 monthly subscription. And then on top of that, I have to pay $2 for each of my 3 albums. So let's look at what this looks like on our table. So remember, when I had an X value, our X is how many albums we downloaded. At 0 downloads, I had to pay $3 for my monthly subscription. Then when I bought 1 album, I had to add that $2 on to give me a $5 fee. For 2 albums, I had to pay $7. And then for 3 albums, I paid $9. So what I want you to do is remember, our first task was to complete the table for 4, 5, and 10 albums. I want you to take a moment and either build it or use your table to continue the pattern and figure out what figure 4, 5, and 10 would give us. So I'm going to give you a moment to work on that. And I am going to build while you work so that we can reveal the answer in just a moment. And remember, you can draw it if you don't have anything to build with. Okay, so there's one of 2 ways you could have done 4 albums. So I want us to look for a pattern first because we are just going up by 1 album every time. And I hope that by now you have noticed that every time we went up, we added that $2 fee. So using that reasoning, we can continue our pattern and say that for 4 albums, we would pay $11. And for 5 albums, we would pay $13. But 10 is a much bigger leap because before we were doing a +1 every time, but now we're going up by 5. So I can't just keep adding 2. I mean, I could, but surely there is a more efficient way for us to make our prediction for 10. So I want us to visualize what's happening. We know my initial value, what I started with, was a $3 service fee. We know that. I know I have to pay $3 somewhere. We know we're buying 10 albums and that every one of those albums cost $2. So we might want to look at a rule, we might want to visualize. We might want to say 10 albums is going to cost me $20 because 10 times 2 is going to give me that 20, and then I have to pay that $3 initial fee. Okay? So that knocks off table. The next thing we were asked to do is to build a graph. So we're just going to take this table of values and we're going to put it on our coordinate plane over here. Now notice I've already gone ahead and scaled it for you. We've got our x-axis. This is our independent axis, and that represents the number of albums downloaded because this is what we control as a consumer. I control how many albums I download. Okay? On the y-axis, this is where we're going to put our f of x, or our dependent value. This is how much I'm going to pay each month based off of how many albums I am going to purchase. So I'm going to go ahead and start with my initial fee, my initial value, which is $3 for 0 albums. No matter what, I have to pay that $3. All right, from there, if I purchased 1 album, I am going to have to go up $2 in value and pay $5, okay? Following that pattern, every time I am going up $2 for the albums that I am purchasing. Now I want you to take a moment, continue your graph. I want you to go ahead and put in your information for 4 albums, excuse me, for 5, and you could even follow that pattern all the way to 10, or you could skip straight ahead to 10 if you needed to. So I want you to pay attention to some things. So we talked about, this is my initial value, right? This is my y-intercept. We also talked about our rate of change earlier. That was one of our goals, identifying that rate of change. So let's look at what that looks like. We said that for every 1 album that we purchased, the price would go up $2. So we're seeing that pattern continue over and over and over again. So for every 1 album, I'm paying $2. So that's that constant rate of change that we're talking about that we see with linear functions. Now, if I asked you to make a larger prediction, that might be difficult using a table or a graph. So for example, if I skipped ahead to this bonus task and I asked you to predict the monthly cost for 100 downloads, well, you don't want to make a table for that. That's going to take a little bit too much time. So what we're going to want to do is we're going to create a function rule. We're going to write a rule in function notation that's going to help us make predictions. I just watched the Grammy. I want to buy all the albums now. So I might need to know this. So let's take the information that we know and write that function rule. So we know that our rule is going to be written as f of x equals mx plus b. Now thinking back to your prior knowledge from slope-intercept form, we know that m represents our slope, but today we learned a new term for that. We learned that that is also referred to as our rate of change. And b, we know from our previous lessons with the slope-intercept form, b represents our y-intercept, but our new term that we learned for that today is our initial value. So b is also going to be the initial value. And so now we should have the information that we need to put the pieces together and write a rule in function notation. So here we go. F of x equals my rate of change. So at what rate, how much more money am I paying for every album I purchase? So I notice that for every new album I buy, I pay an extra $2. And I can also see that here in my scenario where I see that $2 per album. So that is going to give me my $2 as my rate of change. I also need to know what my initial value is. And again, looking back at my word problem, that $3 fixed fee, that monthly subscription, that's where that's going to come in. All right. So now I can look at any version of this problem. Remember, I told you at the beginning, we had scenarios, we had tables, we had graphs, we had rules. I can see in each of these where I have a rate of change and an initial value. Rate of change, initial value, rate of change, initial value, and then in my equation or in my linear function, rate of change, initial value. It's there. We just have to figure out how to put those pieces together. So I'm going to come back to our PowerPoint and bring it all together with what we talked about our goal was today. So I told you today that we were going to build linear functions, and that is the first thing that we did. We built multiple linear functions. We looked at scenarios, we looked at tables, we looked at graphs. We even looked at using manipulatives to do that. Then we identified the rate of change and the initial value in all of those situations. And then the last thing we were supposed to do is interpret that rate of change. Now, by referring to the rate of change as $2 per album, instead of saying my slope is 2, that is that connection, that is that interpretation of what the rate of change actually means. By looking at that $3 fixed fee as a subscription, that is how we interpret the initial value in our linear function. So you guys worked really hard today. Remember your challenge problem. We didn't do it together, but I want you to use that rule that we wrote together, our f of x equals 2x plus 3, and I want you to see, can I predict how much my monthly cost would be if I purchased that 100 albums, because I have a lot of music and a lot of chores and a lot of working out to do. How much would that cost me if I wanted to do that? So again, I'm very proud of all of your hard work that you put in today as you worked with these functions. And I just want to say thank you to, it's on my PowerPoint, thank you to SlidesGo for the PowerPoint template. And I was so happy to work with you students. I hope to see you again soon for future lessons.